have Jimmy, that's Jamshed Bhivandiwala, who's a senior faculty member in terms of the number of years that he's been teaching. And he's one of our most respected and kind of stalwart in this field of technology as well as design. He has taken electives in the school dealing with genealogy and architecture. Interesting electives and very good lectures. So I've invited him to do this lecture with regards to this material steel because I think his expertise will help us a lot in the class. Yeah. So welcome, Jimmy.
Thanks, Mamta. Uh, usually I take the history class with this class. Uh, and I do not know if you ever interacted with your seniors. They'd let you know what kind of classes usually happen in my class. Usually they are fun. History classes in my class are fun. For some reason, the college has decided not to continue with history, and so you should look at your syllabus if you ever get the time and talk to your seniors. Yeah. I should thank Mamta that a couple of days back I was with her in college. That most of you all know we have started attending college. So she did say that I'd like someone to talk on steel. And so I said that, yeah, there is a particular topic that I could talk on, which I think is very important. And that led to quickly in a day putting a presentation together. I'm sorry I had to ask. I'm sorry I had to ask you all to join, so to say. I had asked you to join a little early because I had to leave by 9:15, 9:20. So I requested Mamta to call you all early. What I'll do is I'll share my screen and we'll start. Am I clear, Mamta?
Yes, Jimmy. Are you able to share your screen?
Yeah.
Yeah.
Can you see my screen?
Yes, Jimmy. You will
Okay.
have to go full screen.
Yeah, I'm going full screen.
Okay.
Yeah.
Yeah.
So today we are going to talk about largely what we're going to talk about is how when we work with steel, we just can't deal it. We can't just deal it like any other material. Yeah, and you most of the time, we think steel as any other material like timber or concrete. Uh, we could make some of the biggest mistakes in our times by saying that instead of concrete we could build in steel, but its implications can be very drastic. So to say, my today's presentation says how to design appropriately with mild steel. Yeah. And I'm going to start with the class with these two images. The first is the bridge of Firth of Forth Bridge in London, and the other is our well-known Worli Sea Link. If since I don't have much time in today's class, I won't ask you what's the difference. I'll go directly by saying that the first one uses extensive amount of steel because it uses steel in its, so to say, as a cross section. Yeah, it uses cross sectional members. Yeah, or rolled steel to make girders, and that's using this particular system in which this bridge is made is known as the Gerber beam system. This particular bridging system, yeah, uses a lot of steel to make various kind of strutting girders in order to be able to span these distances. Whereas if you look at in today's day and time, most of our bridges is suspension types. Yeah. So we have a suspension bridge. We have a suspension bridge whereby you have lightweight cables. Yeah. They're as good as strings. Lightweight cables that are yeah, that can hold or that can pull the complete span of the bridge across the bay. And that's what makes today's understanding of using steel in its minimum cross section, yeah, to help us in a maximum manner, because in what we understand, steel is, yeah, steel is weight is measured in by way of weight. So the lesser the steel we use, the less economic or the wiser we are. Yeah. So if you look at this illustrations that I've put on the left, yeah, the illustration shows that a bucket foot full of wet clothes, yeah, the weight of a bucket full of wet clothes would actually require a heavy cross section, metal cross section, maybe a tube or a pipe, to take its load. Yeah, to take the load of a bucket full of wet clothes, like that the girl is holding. Yeah, she's finding it difficult to pick it up, so she's put it on this pillar. Yeah, and the pillar needs to be of a sizable cross section to be able to take the weight of that wet clothes. But if I convert that metal rod or that support to a string, a metal string, yeah, I would use perhaps 1/10 of its material in by way of making the string, and I would be able to dry all the clothes on it, whereby all the weight of the wet clothes could be transferred on 1/10 of the material that is there. So considering the property of steel, that it is can be used so very well in tension, yeah, we can use minimal cross section, minimum of its material, to achieve maximum out of it. Yeah, and because steel is measured in weight, it proves to be really economical. So what I'm trying to say is that if at any point of time we start replacing compression members as tension with steel, yeah, we would make a very big mistake, because we would use a large amount of cross section of the material and thereby pay from our noses and make the project go completely haywire. Yeah, it is believed, it is believed that steel is 60 times as expensive to concrete. And we all know that concrete is can be used very well in compression. Yeah, it is meant to be used for compression, some material designed for compression, as compared to steel that is great in tension. So if we know how to use a material, yeah, then but naturally we would also have a different way to use the material or design with the material differently. Yeah, so suspension bridges in that sense, yeah, suspension bridges in that sense is the wisest way, yeah, to use steel to be able to take great amount of loads like that of rolling loads that come in bridges. So if I go a little back in history, I'll take a small overview. I know Mamta has already started with the idea of the Crystal Palace and the Industrial Revolution in some sense. But we should not forget, till very recently, yeah, till very recently, we did use steel to build in compression. Yeah, the day we started building high, yeah, we started going higher, we knew we could not depend on masonry, yeah, and the greatest of the skyscrapers in the Americas or all over the world have been built in steel, because steel has the great property of not being able to work in parts and pieces. It's not in situ. So it becomes very easy to fabricate the parts in a plant, get them on site and bolt them at whatever height that is there. Okay. In cold conditions like those abroad, yeah, it becomes difficult at times to pour concrete. Till very recently, only that I know that the Burj Khalifa has its entire internal core and entire structural system in concrete. And that was for the first time a big breakthrough how to use concrete for high rise buildings. Otherwise, most high rise buildings were built in steel. That means the structure was built in steel. Most of their members were in compression, which is not advisable. And that is why property prices in high-rise buildings went so haywire or were so expensive because they used the material itself in the most expensive manner. Yeah. So so it's not that, but just imagine if you'd be designing a 3-story, 4-story building, yeah, and you'd actually design the building in the normal way by putting columns, by putting beams, yeah. And if your client came and told you that why can't we construct this building in steel? We can just replace the columns and beams in steel. Perhaps that would be one of the biggest mistakes he would make by advising you to do that, because the cost of construction would go completely haywire. Yeah. And because you're not using the material optimally. Yeah. If that's the point that I'm trying to get through, and I hope I'm being able to get through no sooner than later. Yeah. So history has shown that most skyscrapers have used steel in compression, and not till very recently. Otherwise, steel has been used in order to create large span and lightweight structures. Like if you see the image to your left left hand left hand top corner, it shows that you have a concrete structure and you'd like to add a floor. You'd like to add a lightweight floor. And so perhaps you'd do an extension in steel because you'd want the structure to be lightweight, because a lightweight structure, yeah, not because of its load, yeah, because of its economics, because it is wise to build lightweight. And if you have to build lightweight, then it should come to you that I should use steel, because being lightweight and working with steel are something that go hand in hand with each other. As compared to the other two structures where you see industrial buildings, yeah, it is a favored material for industrial buildings, largely for large spans, because while using large spans, I'd want cross sections to be minimal, yeah, either for use for functional purposes or to keep it lightweight. Or you could say most industrial buildings have roofing systems that are not accessed. Why would I use something heavy if I'd want to make a lightweight roof? In case I want to work with a lightweight roof, then I think to work with steel. Even where I do want to work as conventional buildings, whereby I'd work with column beam structure, where I work with column beam structure, I'd try maximum to use minimum material. And how would I do that? I'd use what are called as open web girders. Yeah. So to the left hand corner, topmost corner, what you see is an open web, lightweight, tubular girder. Yeah. And you could see that implemented to the left. Even where I am using I sections or cold or hot rolled sections for beams, you can see very clearly that I, I'm using what is called as a castellated member. A castellated member is where I use a smaller member, cut these openings amongst them and join the member in order to get maximum out of a minimal member. And these castellated holes try to make the member as lightweight as possible. Don't forget, the lighter the building is, my lighter are my columns, lighter is my foundation. So it has a cascading effect on the overall material use of the building and finally the cost of the building. So if you want to build with steel, you have to build wisely. Right from the concept, you should be very clear that the concept of the building has to be a lightweight building. Only will you have a lightweight building can you justify the use of working with steel. So post the industrial revolution and at the start of the modern, so to say, modern the of modernism, yeah, I can clearly say, I can use the word not mod. I'm not just using the phrase modern lightly. These are some of the finest modern buildings that Mies van der Rohe built. Yeah. Sorry, I've not labeled the PPT, but I think a recording is going to be available. So you could always refer to. These are the well-known two Mies buildings that actually are on the threshold of modernism. To the left is the Crown Hall um, at IIT Illinois, that uses portal frames, metal portal frames to support a large building inside. Yeah, it's very similar to the building to the left. The building to the left is the National Gallery of Art at Berlin, again by Mies. And Mies used the idea of less is more. Yeah. What better could be the concept of less is more when he used the material steel? He really understood the material in all its economics and in all its dynamics, and that's why coined the phrase of being able to use less material to achieve maximum from it. Yeah. So you could say the father of in the being the father of modernism in using steel in the most advisable manner. Yeah, you could give its due to Mies van der Rohe, to a number of buildings that he built, a number of pavilions that Mies built. Yeah, that was his style of building. And but these two structures, presently the National Gallery of Modern Art has been entirely renovated and open to public just very recently. So Arch Daily, and if you'd go to any of these websites, you'd be able to see some really beautifully refurbished interiors of this pavilion. Another stalwart in structuralism, Buckminster Fuller. Yeah, this is an epic photograph where you have uh, some of a discussion between two generations. On one hand is Buckminster Fuller, Bucky Fuller, that people called him. He was um, he was he was the great pioneer in using steel to create what is well known as the geodesic dome. He believed that that model could have helped in creating various kind of environs, various kind of enclosures, right to the extent that he had given a proposal to cover our well-known Taj Mahal monument with the geodesic dome to safeguard it from pollution. All kinds of proposals, entire city proposals under the geodesic dome. Here you see him interacting with none other than with Sir Norman Foster, sitting across, and Michael Hopkins, and a number of structural engineers who went about in their 90s to create an era that is known as high tech. So the 90s see the 90s see an era which was coined as high tech, yeah, and whereby they use steel in the most ideal manner. They use steel in the most ideal manner, in its most minimalist manner, to get you buildings with identity of steel and glass. Yeah. And it starts, and there are a couple of handful of these architects. Yeah, starting with Foster. Yeah, what you see here is the Salisbury Art Museum. Yeah, whereby he's trying to achieve. It's more like an industrial building with these open web portals. Yeah, big open web portals to have completely free interiors. Yeah, so it's like a large warehouse. It's like a large warehouse of art. Yeah, considering the kind of art that they had. It's a large warehouse of art that is wrapped in a open steel, open web open web lightweight portal that is there. Another two pioneers who have set a threshold for high-tech architecture, yeah, in steel buildings were Renzo Piano and Richard Rogers, by participating in the very well-known competition to get the Pompidou Center in France, in Paris. Yeah, the Pompidou Center, very well known, as you see, is done entirely in lightweight steel, in lightweight steel. I've put the two photographs particularly to show, like that photograph to the left is the well-known elevation, whereby the suspended, walkway, yeah, it's a moving escalator, takes you to the top of the building to view to view the skyline of Paris. Yeah, everybody wants to be along the skyline of Paris to identify oneself with the Eiffel, yeah, the Champs-Élysées, and yeah, the great axis that is there. But if you look at it, the entire weight of this moving escalator is suspended. Yeah, and to the right you are seeing these lightweight girder systems that actually is the support system of the entire building. Yeah, you see this double column very lightweight ties. Yeah, the entire understanding, if you do a structural analysis of the Pompidou Center, you'd be amazed to see that perhaps they've worked with less than conventional use of the material steel. Yeah, if you look at the videos of the Pompidou Center of how these girders were shipped and brought to site, they're amazing, amazing stories. Amazing story right from day one with regards to Pompidou Center, whereby people were highly opposed that why such an industrial building should sit on a cultural site. Yeah, and yeah, it was with the understanding with Rogers and Piano that in case uh, there was public, there was public not acceptance amongst the public, perhaps the building could just open and go. And thankfully that has never taken place. It's the plaza in front is a loved public space. Yeah, and the interiors are used extensively as open exhibitions, multi-spaced open exhibitions, and that's the kind of freedom steel gives to build lightweight, to build in a manner that can collapse, open, and all kinds of things that steel actually provides an advantage with. So another two stalwarts other than Foster, that's Renzo Piano and Richard Rogers. Yeah, and this is the kind of image that I showed that, uh, yeah, steel has worked well with airplane hangars, as you see along the top. Yeah, large A-frames, balanced cantilevers, and suspended roofs using steel ties. Yeah, uh, but more well known has been the use of more well known has been the use of so to say tensile structures. Yeah, whereby steel cables, lightweight steel cables, have been used in tension. Yeah, by just by rightly designing the support systems to create tent like and lightweight structures. Yeah, both along the bottom left and bottom right, to be in a position to make the one of the most lightweight members that are there. Here is Michael Hopkins' two structures that work on the principles that I just spoke on, that is tensile structures and lightweight steel members. Along the top you can see is the Schruberger Cambridge Research Center, yeah, by Michael Anthony Hopkins, and the roofing system, the entire structural system being lightweight, other than the two compression members that actually transfer the load to the ground. The rest are all strings that help hold the building facade as well as the roofing system intact. Yeah, a beautiful derivation from the nomadic tents that we'd had here as part of history. Again, to the bottom is the Renault Assembly Center by Norman Foster again. Yeah, if you look at its support system, lightweight support system, minimal girders, minimal castellated, minimalist castellated hollow sections, and ties, yeah, and lightweight ropes or ties to be in a position to hold this large span structure. Don't forget, it's an assembly center, it needs large spans. And what better in manner in which whereby you can use lightweight steel to be able to create large spans. Yeah, so large spans and steel have gone hand in hand for years together. Yeah, uh, that's, yeah. Again, your Richard Rogers Millennium Dome. Yeah. Again, a huge surface supported by minimalist, minimalist, so to say, piers, pylons that suspend the actual roofing of the entire dome. Yeah. So tension. So tensile members and tension members is the key to being lightweight, to be able to achieve both large spans as well as to be making logical buildings using steel. Yeah. Uh, and that has not only gone so the idea of using steel, yeah, to the left, to the right, as you see, like the logic of using heavy duty I sections, yeah, stanchions, I sections, yeah, in compression is something of the past. Yeah, is something of the past. Would be unadvisable to use compression members in steel. Instead, compression members are now made lightweight, as you see to the left, by using tubular members, lightweight tubular members that perhaps weigh a fraction of these hot rolled heavy duty cross sections. Yeah. And so these lightweight members to the left, yeah, uh, and larger cross sections are achieved by clubbing couple of like you see a couple of hollow sections together using ties or using so to say uh, and getting together large cross sections using minimal so to say minimal weighted hollow members. Yeah. So what I'm trying to say is that on at all levels, not only but naturally, tension members can afford to be really lightweight, but also compression members, yeah, also compressive members have been innovated to be used in a manner whereby you use minimal material and get maximum out of it in order to make the building, in order to be able to make the building, uh, so to say, lightweight and efficient. Here is a compilation of some of the world's well-known parametric surfaces, yeah, that architects have worked with all across the world. Yeah. Most of them, yeah, the Gherkin, the National Gallery at London, yeah, all of these, yeah, the Hearst Tower, yeah, some of these buildings, yeah, they did all show that in today's day and time, most of parametric architecture is achieved, yeah, surfaces, entire surfaces, be it walling systems and entire enclosures are worked extensively with lightweight metrized grid systems. Yeah. But before we get into them, yeah, we'd like to understand that entire surfaces, yeah, can be achieved using these lightweight. What you see here is another stalwart's work. This is Nicholas Grimshaw's Waterloo Station at London. Yeah. And it's a structure that has that's that's very wisely used glass and steel in order to be in order to expose a certain road to people. Yeah. And what you see here is suspended glazing to the right of the structure. To the right of the structure, what you see is member, an arched member from which suspended glazing. You have glazing, glass members. The entire surface is glass that is so very beautifully suspended. And we should all understand that glass has weight. A lot of glass has a lot of weight. And so in today's day and time, what we know very well known as suspended glazing. Yeah. These are diagrams showing suspended glazing. I'm sure you've witnessed these when you've been to malls, multi-storied plaza, multi-storied atrias, yeah, atriums, lobbies, where you see multi-storied levels of glass that are suspended either using glass fins, metal fins, or lightweight trussing, or lightweight girder systems, such that these entire glass walls are supported, whereby your facade is kept visually accessible. Yeah. Just imagine you use heavy duty members like the way you see in these photographs. It actually kills the entire understanding of using glass. So here, along the outside facade, you see lightweight strings, yeah, or lightweight ties that hold the entire the weight of the entire glass facade, and that helps in going with the idea of having the glass facade and working with transparency. What we see here, what we see here is we're going a step ahead. But actually, we spoke about a number of buildings that are 1, 2 storied high, that are form oriented, that have lightweight roofs, and have worked well. But what happens when we intend to go high rise? Can the same principles of using steel in tension or using steel in suspension apply when we go high rise? And so here is a compilation under 4 categories, and under 4 categories to show that as buildings go high rise, as buildings go high rise, uh, we intend to we intend to tackle with lateral loads, wind loads. So most of wind loads are tackled using what are called as wind ties. Yeah. So the first 2 categories, the the first upper two, so to say, categories show how external facades are protected using cross wind ties. Yeah, what you see, what we usually mark as a cross along the facade are nothing but wind ties that that take care of all kind of lateral pressures. The third category actually shows where, yeah, that third category is something that I like to stress upon. It shows where the central core is in concrete. If you'd see paying attention, the central core is concrete, whereas from the central core along the top are floors that are suspended, are floors that are entirely suspended, that take the load actually. So the columns along the floors actually don't transfer their weight downward. They're actually transferring the weight of the floors upward. So the load goes upward onto this central core, and then this concrete central core that is meant to transfer the loads in compression actually transfer the loads to the ground. Yeah. So the third category that we're seeing here, the third line of buildings, is something that should intrigue us, of how to make a multi-storied building, using suspended floors, suspension floors. Yeah. So you'd have a concrete core that would work in compression in some manner, and had and have, yeah, and have floors that are suspended using lightweight ties, because your vertical members are not working, in compression, they are working in tension. Yeah. I'll exemplify this particular category by talking about the renowned Hong Kong Shanghai banking headquarters in Hong Kong, which is renowned buildings, sits along the skyline of Hong Kong, designed again by Norman Foster. Yes, Sir Norman Foster, for his contribution. Yeah, this is the well-known hangar system, and I do not know if you can. I cannot use a cursor, but from what it looks like, the building comprises of hangars. Yeah, yeah, if you see along the facade, there are triangular hangars that are further held using concrete vertical columns to the left, that is very well exemplified. Yeah. So a hanger suspends as good as 5 floors. If you look at these hangers, the triangular hanger actually helps suspend from it 5 floors, and those 5 floors, the load of those 5 floors go to those big super columns. The super columns, yeah. The super column is also a big column. It comprises of 4 columns that are well tied together, and the load transfers vertically down. But the load of the initial 5 floors goes upwards because they are suspended. And if you look at the diagram to the left, to the right, you will actually see that the cross section of the vertical members from which the floors are suspended is actually lightweight, is really lightweight, is nothing that we can imagine. Yeah. So all column systems other than these four super columns that are there, that is actually transferring the load or entire load of the hangers to the ground. The rest of the the rest of the vertical members are all lightweight, because they work in tension. The floors are entirely suspended. I hope you've got these points. I hope I'm being able to portray these points. I'm not taking questions in between. I'll take questions at the end, but I hope I've been able to convey this. So what you see here along the atria is the four super columns to the bottom right hand side. To the bottom right hand side, I have four super columns, and uh, what you see to your left is a complete breakup. Is a complete breakup of how the structural system works. Yeah, the it starts, if you look from below, you have your four super columns, then you have your hanger systems, and then to the left of the hanger systems you have the suspended floors that work with the hanger systems. Yeah, then the load of the glass facade, yeah, and to top it all the services that is there. So it's one of those buildings built way back in the 80s. Yeah, that was path breaking of using suspended members, or using the concept of suspension, not for lightweight ground and two-story structures, but for high rises. Yeah, and that's what made this building, and that's what makes Foster for what he's well known for. Today we have numerous such buildings. Yeah, this is the well-known Macquarie Bank headquarters. Yeah, comprising of offices that are suspended in this large atria that is there, white boxes that suspend that is there. Yeah, it's yeah by SKL Architects. Oh no, uh, this is by Clive Wilkinson. Macquarie Bank headquarters is one of the most recent additions in the for the architectural world to see. Yeah, easily available. You could, if it interests you, you should look at them. By Clive Wilkinson Architects, Macquarie headquarters, whereby suspended meeting rooms and offices work along the large atria that is there. Another such example is by SHL Architects. Yeah, the Nike Credit headquarters, again a financial institution, whereby meeting rooms and staircase blocks are entirely suspended as part of their large atria that is there. So what you look both to the left and the right are suspended meeting rooms. Yeah, and one of my favorites of having suspended staircases. Yeah, along is very rarely you get to see a suspended staircase that has been designed and works so well. The last of my slide, the last of my slide shows we are not behind. This is Mumbai's own Hong Kong Shanghai model. Yeah, this is again a building in the DY Patil campus for its management institute, designed by Foster. Yeah, designed by Foster, is works on the same principle that the Hong Kong Shanghai Tower was built. Is presently under construction. Yeah, you see. Um, five-storied buildings being suspended from the central core. The only thing is that, considering our climate, these are not going to be wrapped in glass, but are going to be wrapped in intricate jali. Yeah, jali works that allows that creates a kind of a facade that allows wind to pass through, but not the harsh sunlight. And its illustration is being showed. It's a building that is being currently worked upon, and its illustration is shown to the uh, left. With this, I'd end. With this, I'd end the presentation. Uh, I'll be more than happy to take any queries. Though I'm really running short of time, I need to run at was to run at 9:30, but I can have 10 minutes to take a couple of queries. Uh, I believe uh, I believe Mamta and Sirish can continue the discussion. Um, they are very capable of continuing the discussion of how one should work with uh, one should work with steel as a material, which is important in its understanding. Yeah, and we can't afford to look at steel in using just in a conventional column and beam manner. Yeah, even if it have to use. So what I tried was trying hard to convey through the presentation is that one cannot afford to design by not having the materiality of the building in mind. If you have to design using steel, then the concepts of working with the material completely change the ball game of how you'd want to work with the material and how the design would be. If you design a building in compression and start replacing and start assigning members in steel, then I think you'd make a big mistake. You'd get your client to go bankrupt in some sense, because every member that you'd use would be 60 times more expensive if it would have been used in concrete. So if a client ever tells you that here you have this building, and we do that a lot of times, we have a lot of repairs. Yeah, we have the building repairs board and all of them that remove members left, right, and center from our buildings and replace them with steel. As far as it is a couple of members, it doesn't make a huge difference. But if you start designing like the way you do it for concrete and start assigning members in steel, then God help your client and the economics that he's working with. Yeah, I'm done with. If there are any queries, I could take a couple of queries before I hand over the platform to Mamta and Sirish. I'm sure Sirish is also around.
Yeah, he's around. He's in the first year workshop. He'll come back.
Sure, sure. Any
Yeah.
queries that I
Okay,
could take?
questions?
Uh,
Questions?
I hope uh, I hope I
Yes,
could.
Shravan, go
Yeah,
ahead.
yeah.
So when we're so when we're talking about steel, we talked about in terms of two ways. One is not using it directly as a column and beam as we do with RCC, and also the idea of the lightweight members, which is uh, the I'm sorry, the term missed me because my connection was a bit loose, but where the hexagons were cut in the girders where the hexagons were cut in the
Yeah, if
IV.
you have to use, yeah, exactly. First of all, you'd avoid using it in a column beam manner. If you'd want to use it in a column beam manner, perhaps your columns don't need to, the loads of your column perhaps need not come down. They could go upward. Yeah. For once, I'm propagating that column loads need not come down. Column loads can go upwards. Yeah, someone has rightly said castellated beams. Yes. So if column loads go upwards, they are not in compression, they are in suspension or in tension, whereby cross section of your member decreases extensively, but beams remain as beams. So how do you take care of beams to make floors? So beams could either be castellated, they could be open web, tubular, all of those. So there's a wide area of this kind of designing using steel. But naturally, this is more like an introductory class, so we're not going to. But there's extensive material and extensive work done to show how steel can be used in the most lightweight manner that is possible. Because the lightweight the member is, it's directly proportionate to the cost of construction. Yeah, it completely makes your building viable, as to because everybody works with a budget. So if I'd work with a steel building for a given budget, then but naturally the building or can has to be lightweight. If I start making a heavy building in steel, perhaps my cost of construction and the budget of my building would go entirely haywire. So you've got it right. Yeah, in some sense, you've got it right. but naturally no concept can be understood directly at the first time. A little bit of probing and a little bit of so to say looking up the web and your own research can help you, yeah, understand the material and construction using this material better. Anybody else?
Yeah, anyone else?
I think
No pertaining query to any specific thing you have for your IDS or something?
so. The recording is there with you, but naturally,
Yeah.
I do look. I know that it's a little heavy. Yeah, these are concepts, and so they don't sink in so easily. So thankfully, we are recording most of these sessions. Yeah, I'm sure that should help you in some sense. The recording is going to be available. It's a start for you to understand that steel members look different, behave differently, are designed differently. So, in for your IDS or whenever in life you're going to be designing numerous buildings, if ever you start working with steel, then right from day one you know that conceptually that building is to be conceived differently. It cannot be the normal build column beam structure and can afford to be in steel because it would put things completely haywire. Yeah, you have another question, Shravan?
Yeah, this one's a bit more pertaining to IDS. But when we're looking at the kind of concepts we're talking about, we're looking at them in terms of an orthogonal plan. But if we look at them in terms of a radial plan, how differently would that change things? Because the putting beams in the curved form, that would completely kind of change the way the force works, right?
No, I don't believe so. Don't forget that any radial or any circle is a circle is a segment of straight lines. A circle is nothing but shorter straight lines put together. The world has seen numerous curvilinear buildings, like Gary has done extensive
Get
curvilinear buildings, whereby his entire facades are actually his most curvilicious buildings, like the Walt Disney Center and the Bilbao Museum. All of
Bilbao.
these, yeah, all of these facades are done entirely in lightweight steel cladded with titanium and some fancy materials that he works with. So, and they come under the understanding of parametric architecture. And I did show that one slide. I didn't want to stress on that. Yeah. So parametric
I showed them
surfaces.
the frame. Sorry to interrupt. I showed them the framework of Bilbao last time in my lecture, which is all steel. Yeah.
So most of parametric buildings in today's day and time are entirely executed in steel. So be it radial, curvilinear, whatever that is there. The idea of the space frame. Yeah, the idea of a space frame, which is nothing but a tubular girder in three-dimensional. Yeah, a girder is a member in two-dimensional. When that girder becomes a surface, yeah, where the module becomes from two-dimensional to three-dimensional, becomes a girder. And the idea of the three-dimension becomes a space frame. The idea of a space frame and an undulating space frame works wonderfully well with the concept of parametrics that people have been using extensively. So should be no problem at all. As far as your roofing system, radial roofing system, or whatever that is there, is designed lightweight, yeah, is made as lightweight as possible. You can justify the use of steel. Yeah. I hope I've answered your query.
Yeah, and I'm also anyway looking at a lightweight roof, so that's
Yeah.
perfect then.
Yeah. I'll take leave, Mamta.
Yes,
I'm
Jimmy. Thank
sorry.
you so
I
much. That's
Yeah,
fine.
not
Yeah,
always
that's
a
fine.
pleasure.
Thank you
Bye.
so much. Yeah, for making time out for us.
Thanks.
Bye. Bye. Yeah, guys. Any other questions? No questions. So I'm going to give you an exercise now to do because I think we are missing out on actually looking at these kind of, just 1 minute. Yeah, missing out on the actual feel of metals, that material, and how that two, let's say, two parts of the same material come together, or two different materials come together. So I'm going to do this exercise with you. We'll take a break now. Your class is till 10:30, 10:40, 10:40, right? So what I would like you to do is go hunt in your homes for any everyday object which you would see which has this kind of metal joinery. It can be anything. It doesn't have to do with construction. It doesn't have to do with your windows. It doesn't have to do with any building component, so to speak. But it could be. So look at some everyday objects which use this kind of joinery. It can be from your kitchen, it can be from your cupboards, it can be from your clothes, it can be from anything. Okay, so I want you guys to quickly go. We'll meet again at 10:15. Quickly go and bring these objects, and I want you to share these objects with me. And let's take a look and discuss a couple of them, and the rest of them then you can sketch in your sketchbook and analyze for the next class. Okay, next class we'll
Any
be doing
joinery made from steel, right?
anything, but it has to be metal. It can be a combination of metal and glass, metal and wood, metal and anything. But yeah, see, she's already got something. Oh, it's Shravan, sorry. He's already got something here. What is this, Shravan?
It's an umbrella. Wait, I'm trying to fix my camera
Fantastic.
this thing.
Yeah.
It's a broken
Remove
umbrella,
the
but it's an
blur.
umbrella.
Yeah, remove the blur from the background.
Uh, Background effects. Huh.
Yeah. So now which part do you want to analyze or explain? Where did
There's a bit between the handle and the rest of the umbrella where normally I think there was
and
supposed. Well, there's definitely like a missing part, and I mean, yeah, there's not much, but like the
so
way it's kind of
the
held together.
the more interesting one would be Shravan, where the spokes come, which
Huh.
where there is that dynamic movement. So the joint between the parts where your umbrella folds, since I've given you a kind of idea about butt joints and roller joints and pin joints and all of that, that would be very interesting to see how that joint works when your umbrella folds and opens out, correct? So
And yeah.
what you need to do is take that, see how it works, and give me like a trajectory of sketches that explain that movement. Now, all of you may not get these kind of dynamic joints. It could be a static fixed one, like we saw last time. We looked at shear connections and moment connections. So go and look for all this and bring them to class. We'll meet at 10:15.
Okay. Thank you.
Quick. Yeah.
Mamta, can I ask you something since it's a break?
Yeah, sure,
Um,
sure.
it's for my ideas thing. I'm doing it in bamboo. So can steel and bamboo be can I
Yes.
have like steel
Yes.
beams with bamboo like attached to it?
Yes, 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 very much. So even the joinery of bamboo, if you look at what uh, did the Brio encounter architecture Brio encounter happen last year when you were in the first year?
Yeah. Yeah.
Okay, look up their website and see the kind of composite joinery that they do with bamboo and metal.
Okay,
Okay,
thank you.
because now, in fact, this is the way that we need to start thinking. We can't fixate ourselves with that idea of huge masonry working by itself. We can't think of bamboo working by itself. We're looking at these composite elements to help us move ahead in technology, right? So that we achieve something better.
Okay,
So
thank you.
even, I mean, I'm not saying we are fixated back in time, because even if you look at the warps and wefts that were created by Eladio dynasty in his masonry, you can check his thing on the net. Just type Eladio dynasty and church. You'll see that it's a complete undulating surface created in masonry, but it has these wires that are running through that masonry which allow for it to stand. So in plan, it's a straight thing. In plan, it's straight. It's like a rectangle, but the entire wall is warps and wefts like that. Look it up on the internet. So it's time that we move into this kind of composite construction so that we can achieve, or we can actually say implement it in our design, or get our design to work. We can sort of what do you call it? What's that word, Shravan? Help me out. We can put make our
hybrid
dream
form.
reality. Yeah, whatever. Okay. Yeah. So go and bring me back something from your house. Anyone else wants to ask any questions? Okay, guys, so we'll meet at 10:15.
Okay. Yeah.
Yes, thank you.
Thank you.
Yeah.